Hello, welcome to yet another computer vision tutorial video. In this video, oh my God, I'm so excited. I'm going to show you how to program from scratch, not from scratch, but how to program the raw algorithm for blob detection yourself. And what do I mean by blob detection? So in 2 videos back, I made an example that finds, it's over here. Ah, no, it's over here. Where is it? Okay, over here, that finds this cup that I have taped to my green screen behind me by looking for the average location of all of the red pixels it finds. And this works perfectly beautifully nicely. However, there's a problem. If I add a second cup, look at the average location is in between those 2 things. And I want to be able to track them individually as individual blobs. So how do we do that? So I want to talk about how this algorithm works. So what's going on here? There is an image that the camera is seeing. It is seeing 2 red cups taped to a wall. I don't know what my life has become that I'm taping plastic cups to walls that are painted green, but that's just what it is. Okay, so it's looking at every single pixel and it's asking a question. Is this red? And you can insert something else there. Is this a bright pixel? Is it a dark pixel? Is it a blue pixel? You could be using a connect and depth tracking. Is it a close pixel? Is it a far pixel? There's lots of things you could substitute for this question, but for my demonstration of the algorithm, it's going to work nicely if I ask, is it red? And so the answer is going to be no. Is it red? No. Is it red? No. Is it red? No. 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 It's a very negative program. It's just no, 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 no. But eventually, at some point, it gets to over here. Is it red? And it's like, yes, yes, it's red. So if it's red, then we have to ask the question, did I find a red pixel before, or is this a new? Have I found the first red pixel? And as soon as it's found the first red pixel, it has to make a blob. So the blob is going to be a Java class, an object, which is a blob. It's going to say, I found the first red pixel, so I'm making a blob object. And I'm going to call this blob A. And blob A has an x, a y, and a width and a height. It's like a little rectangle. Now, what happens next? Oh, it goes to the next pixel. Is it red? Yes, it's red. Yes, it's red. Is it near one of the existing blobs? It is. So let's just put it in blob A, and maybe blob A gets a little wider. Then it looks for the next pixel. Oh, it's near blob A. Put it in blob A, make it a little wider. It keeps going, then it says no, 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 no. Finds another one. Oh, it's part of blob A. No, 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 no. And eventually it gets down here and it finds another pixel. Yes. Well, is it near blob A? And it suddenly realizes no. Look at that. That distance is greater than some threshold. It's time for me to make another blob. So it's looking for all the red pixels and finding the clusters of red pixels near each other within some that are far enough by some threshold amount. So that's the algorithm we need to program. And the blob I'm going to think of really just as a rectangle. It's going to have an x and a y, and it's going to have a width and a height. Okay? So let's see if we can make that happen. Okay, so now what do I need to do? Okay, the first thing I'm going to do is I'm going to make a blob, a new tab in this processing sketch. Okay, good. And I'm going to give it an x, a y, and a width and a height. And then I need a constructor. And the constructor, when I make the first blob, it gets an x and a y. This is tricky. So the x is going to be that x, the y is going to be that y, and the width is going to be a width of 1, and the height is going to be a height of 1. Okay, great. So that's what happens when I first make the blob. Oops. Now let's think about this. So now let's go back to this algorithm. And I don't need, what do I need? I need to have some sort of variable list of blobs. So I'm going to make an array list of blob objects. Now, if array lists are new to you, it's like a flexibly sized array. So I can start with none, and I can add more, and that sort of thing. And this is something that I encourage you to look into. And one thing that I'm going to have to do, I've lost my train of thought. Okay, one thing I'm going to have to do is say blobs.clear. So this is something that's going to be really, really key, and I'm going to bring this up again later. But what this algorithm is going to do is just show me a snapshot of blobs at this moment in time, and then a snapshot of blobs at the next moment in time. But it's not going to know which blob is which over time, but I'm going to get to that in a future video. We'll talk more about that in a little bit. So I don't need this average location anymore. I don't need this count. This was all from my previous example. But what I'm doing here is what happens as soon as I find a pixel that meets this red threshold. Well, what I need to do, what I'm going to do is just say blob b is a new blob at that particular x and y. And then I'm going to say blobs.add blob b. So this is the idea. Anytime I find a pixel, I make a new blob. Only I don't always make a new blob, right? I only make a new blob. Well, when would I make a new blob? If blobs is empty, then I make a new blob, right? So if there are no blobs and I found a pixel, it has to be. Now, otherwise, and I'm going to do this in a slightly different way, but another way that I could do that is for every blob, let's add a Boolean variable saying found is false. So I want to loop through every blob and say, is one of these blobs my home? So if there are no blobs, by the way, if not found, then I add a new blob to that array list. So this is the algorithm. It's over here. I start by assuming, well, I haven't found a blob that's a home for this pixel. But now I'm going to look through all the blobs and see if one of those is a home. If after that loop, which I haven't written yet, I still haven't found one, then this pixel is a new blob. OK. So the very first thing I need to do is say, what is the distance? Or let's write it this way. If b contains or is near, let's write a function called is near. I think actually in an example that I saw, it was called that. If blob is near this particular xy point. So that's one thing I can do to check. What's the distance between this xy point and this particular blob? So let's go to the blob now and say let's write a function that's a Boolean function. It's got to return true or false. Is near, and it gets an x. I'm going to call this I'll just use x underscore. I should come up with a different, somebody suggest a better variable name, but if this particular xy point is near, I need to either return true or false. So the first thing I need to do is what's the distance between xy and xy? So I'm going to call this px for pixel x. And let's do that up here too. I don't like this underscore thing. It looks so obnoxious. No, I don't have any, not that I have any problems with underscores. The underscores are lovely, nice characters. But I'm going to call it px for pixel x. But actually, here's the thing. I actually want to test, I think I want to test if it's near the center of the blob, not the corner of the blob. So one thing I'm going to do is say cx for center x is x plus w divided by 2. And cy is x plus y plus h divided by 2. That's finding the center, right? X plus the width. No, that's not the center. X plus the width divided by 2. Don't be ridiculous. X plus width divided by 2. Thank you very much. Y plus height divided by 2. That's the center, right? If you have a rectangle, x plus the width of the rectangle divided by 2, that's the center location. So I want to know if that pixel is within some distance. Now, again, let's use distance squared to don't I have distance squared in this example? Right here. There it is. Oh, but it's only, that's a 3D distance. Let's make a 2D version of it. I have this from a previous example where I was using color. By the way, did you know in Java, you can just have a function with the same name? As long as it's two different arguments, two different sets of arguments, it'll know which one to call. That's called method overloading. OK, so I'm going to go back here, and I'm going to say if the distance is less than some particular threshold. I don't know what's a good distance. Let's say 50 pixels away. If it's within, let's say it's within 25 pixels, then return true. And this is definitely a variable that I'm going to want to make something that I can change. Otherwise, return false. OK? So now what I'm going to do is, and all this stuff is irrelevant. This was from my previous example. So if a blob is near xy, then first of all I want to do is blob add xy. I want to add that point to the blob. And then I want to say found equals true. And then I'm going to say break. Now, there's a little bit of a problem here where I probably should check all of the blobs and find like the one that it's closest to. But I'm not going to worry about that right now. I'm just going to do this loop to find, and I'm just going to find the first one. So now I need to add that xy. So here, I need to write a function add that pixel x and pixel y. So what does that do? Well, the thing that I need to change is I need to check. Ooh, this is tricky here. Let's think about this for a second. I'm going to use a diagram. There's probably a smarter way I could do this. Maybe somebody in the chat or will give me a suggestion. But let's say at some point I have a blob like this. And it has an x and y, and it has a width and a height. So the first thing I need to figure out is that pixel inside this rectangle? All right. If it's inside that rectangle, I don't do anything. If it's over here, I suddenly want my rectangle to be like that. If it's over here, I suddenly want my rectangle to be like that. So you know what I think I want to change about my blob? I'm going to change something. I'm going to have the blob, instead of having x, y, w, h, I'm going to have min x, min y, max x, max y. I'm just going to keep track of the top left and bottom right corner of the blob. And actually, that allows me to have this argument be x, y. And I'm just going to say, when the blob starts, the minimum x and the minimum y, and the maximum x and the maximum y. And I could have called those bottom xy, top xy. But anyway, all of those are that. Now, when I check if it's near, now I am getting the average. So I'm going to say minimum x plus maximum x divided by 2. And minimum y plus maximum y divided by 2. The distance is still the same thing between this x, y. And then the add function is going to be easier. Because what I'm going to do is I'm going to say minimum x equals the minimum of x and minimum x. This is a processing function minimum that says if x is less than minimum x, whichever one of these is less, use that one. So I should be able to just do this. And the same thing here, like this. So I just want to get, I could have written if statements like if x is less than minimum x, then the minimum x is now x, that sort of thing. But this should do that trick. This should add the blob. OK? And then, by the way, what do I've got here? I've got everything I need to draw a rectangle. So I'm going to write a function called show. And I'm going to say stroke 0, fill 255. And I'm going to say just stroke weight 2, so I make sure it's kind of thick. And then I'm going to say rect mode corners. By the way, in processing, the rectangle mode corners allows you to specify the top left and the bottom right of a rectangle. And those are the values I have. So I'm going to say rect min x, min y, max x, max y. So I added a whole bunch. The blob does a couple things. It checks to see if a pixel is near it and can say true or false. It also can add that pixel to expand or contract its rectangle. And then it can also draw that rectangle. And now in this particular algorithm, this is it. I think I've got everything here. If it's near, where am I? If it's near, add that point. I found it. Otherwise, add a new blob. And then at the end here, after I go through all the pixels, I should be able to go through all of the blobs and say blob.show. OK, I'm sure I missed something. But let's try running it. The variable px does not exist. Oh, right, because this is now x and y. Uh-oh, max x equals x. I have an error in the chat. Someone's telling me there's an error in the constructor. Max, thank you. OK, so this was a big error. That would have caused me a major problem. OK, here we go. Let's see what I've got here. Now, ooh, what is that craziness? Oh, look at this. It's finding zillions of little tiny blobs. Oh, look at all the little tiny blobs. Little tiny blobs. Look, find some more little tiny blobs. So I think my distance threshold needs to be a little bit bigger. 25 pixels. So that's just something I need to make a variable. So I want to make this a variable. Let's just do this right now. Oh, right, because this all the way was distance squared. So it wasn't so crazy. So I'm going to make a, so this is the color threshold. And I want to make a distance threshold. And I'm going to say that's equal to 25, just having these be the same. And first of all, this needs to be distance threshold times distance threshold. And I'm going to add a, just right now, I'm going to add key pressed function. And I'm going to say if the key equals A, then distance threshold plus plus. Else if key equals Z, and this is a really quick way for me to just adjust that, minus minus, and then print line distance threshold, just so I can modify it on the fly. Here we go. Come on, everybody. Here come the blobs. Here come the blobs. Blobs, the musical. Here. Oh, yeah, much better. So we can see here now, ta-da! Now, this is still getting multiple blobs, and I can tweak things. For example, I should probably click on the color. Look, my lips are a blob. My fingers are a blob. But you can see one thing I can do here, let's zoom into this, is I can consider blobs of a certain size to be useless. So I can, one thing I can do is say here, right? I can say if blob dot size, if b dot size is greater than 100. For example, I can only show right now blobs that have a certain size, and there is no size function, but I could write one. And I could just say, return max x minus min x times max y minus min y. Like the width and the height of the blob, so to speak. I multiply them together. And I could say, they have to be greater than 500. This would get rid of small blobs. Right. Oh, and that threshold. Yeah. I meant to, by the way. So, this is also what I can change here. Let me add this second one. And you can see how nicely this is working now. My arm is blocked. Let me go over here. And you can see what I'm getting. Now, I could still, that threshold, you can see that there's two blobs up top there. Let me make that threshold. If I keep making that threshold, there we go. Now it's just one blob. And again, I could do things like interpolate or whatever. And let's do this. And here we are. And oh boy, we have to do something. Ah, no! Blobs! Blobs! I'm being eaten by the blobs. That's not what I meant to do. Come on, give me some red. I am Blob Man. Okay, anyway. Whatever, you get the point. So this, I think, stop music, Steve. So I think I've shown you the basic idea of the blob algorithm. There's, I think, a bunch of things I could improve here. One, I could make a nicer interface to kind of tweak these thresholds of color, the distance threshold. It might be nice to sort of draw the rectangle, the blob rectangle with some alpha so I could see what's behind it. One thing that's really kind of important about this to mention, I'll mention this again, is come back to me, code, is that, whoops, it's funny, it worked much better without me clicking on it. Anyway, is that there's no sense of, so by the way, this distance, that threshold should really be like 75 to start with. And let's make this let's make this less. I don't know what I'm doing here. So one of the things that's really important is, let's say you wanted to have an image follow this cup and an image follow this cup. Look, it's working beautifully right now. An image follow this cup and an image follow this cup. Like, what if I wanted to put a cat over here and a dog over here? Well, I'm not always gonna, I might, this blob is gonna be found first because of the way I'm iterating through the pixels. So this blob is always gonna be blob 0. But now this blob is gonna be blob 0. This cup, that is. It's blob 0, but it's this other cup. So these blobs there's no way, these blobs don't have ID numbers. There's no way to track them over time. However, That is something we could add. So I'm going to show you how to do that. Boy, this is working so nicely. I'm so pleased. Well, look, I could put Mickey Mouse ears on myself. Anyway, I'm going to go do this on my own time. You don't need to like watch me do the weird stuff with the blob. But I'm going to do that in a future video. Let me say one last thing. So ultimately, you know, if you want to do this, and I'm going to show this in another video, there are ample sets of processing libraries. There's blob detection, there's OpenCV, there's a lot of processing libraries that will do this. There's also something that I haven't implemented in this algorithm, which is actually to find the contours of this cup. I'm just finding kind of the minimum maximum area of the blob. So those types of things I would recommend thinking about, contours. And so I'm going to show you at some point how to do this stuff without writing all the code for yourself, but just use a library that does the same thing. But it is interesting to see. One thing that I think is good to see about this is a lot of the libraries are built in just to look for bright or dark blobs. And so you would have to apply some type of brightness threshold to the image first before passing it to the blob detection library, which would be fine. But custom baking it yourself, you can just like look for a specific color, like red. OK. Thank you for watching this blob detection video. I'm hoping it was useful, and I'll see you in the future computer vision videos. Goodbye.